Good morning, everyone. Thank you for joining us in this session on provisioning the IoT. My name is Sander Mak, and I'm here with my coworker Paul Bakker. We both work for Luminous Technologies, and this is a company in the Netherlands. And both of our backgrounds are mainly in doing server-side Java development. And you might be wondering, okay, so why you're talking about IoT and provisioning now? And well, what we saw in our projects is that more and more we were encountering clients who didn't just need a web application or server-side backend, but also wanted to incorporate different devices into their strategy, into their solutions. And a lot of times these devices were outside of the context of our projects, but more and more we see the general purpose computing coming up also in IoT devices. And we were asked to come up with a complete solution from server to device to end user, etc. And we have experience developing and also deploying and provisioning on the server side. And we ask ourselves the question, okay, what's going to happen if we need to do this for devices and for more and more diverse deployment targets as well? Because it's a totally different ballgame. So in this talk, we want to take you through our solution and our take on what we're doing with devices in our solutions. And I want to start with a little bit more context about IoT, because you can understand fairly different things under the same term. So we're going to sketch our context, our idea of what IoT means for our solutions. And after that, Paul will show you a demo of our solution and what we are currently using to do deployments of Java code to devices for our customers. And after this demo, which uses Apache ACE, which is an open source project for doing provisioning and deployment, I will dive into the details of Apache ACE and talk a little bit about the architecture and about all the moving parts that are involved in using such a provisioning solution. So when you think about provisioning, at least when we think about provisioning, the first thing that we think about is really all the server-side stuff. So also at DevNation, there's lots of talking about Docker, about Kubernetes, about all sorts of automation tools to do deployments on your server side. And typically, you're in an environment where you have pretty much full control of your network, of the tools that you're using. You have a reliable network as opposed to a more unreliable network, sometimes in the IoT context. And I would say it's pretty much a solved problem. We have so much tools to do server provisioning currently and to do automation on that side. Yeah, there's just enough to pick from there. At the other end of the spectrum, you can also think about, okay, there's also this whole mobile side of the world. And whereas the server world, where we want to deploy our web application to some server, is more push-based, the whole mobile world is more pull-based. I, as a customer, have a device and I want to install some software that some third-party developer created, and I can do so through an app store. And this works fairly well from the consumer point of view and from the user point of view. It's not for nothing that those app stores are hugely popular. But from a developer point of view, it's really not that nice, right? I mean, they're completely walled gardens, and what you can put in there and what you can provision through these app stores is really limited sometimes. So this is not something that we wanted to have in our end-to-end solutions for these projects that I was talking about. So what we really wanted was sort of a mix between a world where we control what ends up on the devices, but still, it has to work in a completely different context than those cloud servers or our bare metal machines that we have full control of and where we are sort of the master of the universe. So here in the middle is where we end up when we think about provisioning for the IoT. And in this middle part, we don't always have a reliable network. And we don't always control which devices we are going to deploy to. Sometimes we do, sometimes we don't. And there are all kinds of different questions that come up there. So when people start thinking about, okay, I have devices, I don't know, point of sales devices or other embedded devices that are part of my complete architecture, well, I have a good idea. Why don't we let these devices just phone home, maybe at startup time, and when they boot, they check with the central server and see whether there's some FTP package with a later modification date than what we already have. Just download it and then run that. So it sounds very simple, and it can work, and actually there are systems doing this. But you can also imagine that it's not really a very nice solution. For starters, if you do this and you have to download your whole new application before the device even comes up, well, that's not really user-friendly, and whether or not that's a problem, that depends on your use case, of course. But it's not really nice to having to download this all at once. And what if something goes wrong? I mean, you don't really have any insight into what's happening on the device. You don't really have any control over what's going to happen after the download has finished, etc. So it's simple, but it's also simplistic. Not something that we were happy to employ as a solution. So we started drafting a sort of a wish list. We were saying to ourselves, okay, what kind of characteristics do we want in the provisioning solution for our devices? And one of the things that was pretty high on the list is some form of modularity. And what I mean by this is that the software that we create for the devices often comes in slightly different variations, where the core of the functionality is the same, but for some parts of the system we need to add additional features or leave off features. So we want to do some form of feature composition, and this has to be not only a compile time and design time thing, but preferably also something that we can push through all the way until runtime when provisioning these features to the devices. And maybe we can even add features at a later date to a device, or toggle features on and off, whatever. So this is something that was pretty high up on the list. The other one has to do with the fact that the devices that we were targeting were on either expensive networks or unreliable networks. So being efficient with your bandwidth was really something that we wanted to do. So obviously, if you always push your full application and your full binary, even when just one line of code has changed, that's not really efficient. So we want to, A, avoid unnecessary updates, and B, if we're going to update, we want to update the smallest part possible. Automation, well, it all begins with the question, of course, how can we automate this? Because if you are provisioning a couple of servers, you might get away with doing it by hand. But if you have a couple of hundred or 1,000 devices, then you really don't want to do it manually anymore. Also, the automation should not just be one way, so pushing the software, but also seeing, okay, is it running correctly on the device? And what is running where? And last but not least, of course, there's the security aspect. So sometimes it's okay if your software can just be pulled by any device and run there. And sometimes you want to be more specific about which types of devices or which class of devices are allowed to actually run the software that we want to provision. So it's quite a long list, but okay, that was a starting point. And before moving on, I really want to stress that this is our view of what IoT means for us in our context. We're not talking about the interpretation of IoT where you have a swarm of millions of sensors going on, etc., etc. We are really talking about solutions where you have an enterprise system and, for example, a couple of 1,000 or 10,000 devices that are connected to that enterprise system. Think of electric car charging poles in a certain area, or think of the devices that sometimes are put into vehicles that they use for tracking packages, etc., etc., or even an ATM-like scenario. So this is sort of the devices that we are thinking of, not the tiny microprocessors that have these mesh networks, etc., and so on. So that's the context for what we were looking at. It's also not about managing the lower layers of the device itself. We're really interested in doing sort of the upper application layer here. So there are some standards to do provisioning and management of the lower layers for devices as well. If you look at, for example, the cellular and mobile devices, you have the Open Mobile Alliance device management standard. And there's also something called lightweight machine-to-machine provisioning. But that's all geared towards the more lower end of the spectrum on the devices. And we want to be able to provision, in this case, Java code to the device and have it run there. So, a little example. We all know this car, right? And we all know that it's mostly made of software. So, of course, the software has to be updated sometimes. And I found this nice screenshot, and it's not really readable here, but it actually says, okay, you have to pick some time to apply this update because you can't really drive while I'm updating. And by the way, don't go away from your car because for about 15 minutes, the alarm and the locks won't work either. So this is really an example of sort of pushing a monolithic update and doing it directly in place. And for some of the subsystems of a Tesla, I can really imagine that you want that. You don't want to in-flight upgrade your braking system or whatever. But for other things like, for example, I don't know, the in-car entertainment system, you could really see that it would be nicer to do this in a more modular fashion where you can just do it in-flight at runtime and just update pieces of the code. So we thought, why not create a little demo and show how that could be done using Apache ACE and the solution that we have. So with that, I give it to Paul for the demo.
All right. So it's obviously not very convenient to take Teslas in your bag and try to get through the airport. So we decided on something a little bit simpler and lighter. So what we have here is we have two machines here. Those are just Intel NUCs, so those are just small computers basically, easy to take. And both of them represent a car. And you can see the cars are not exactly equal. And that's because our software is also not exactly equal for different versions that we have. So let's take a look at what we're going to do exactly. So we have two different cars. And each car has its own version of the software that we have. So we have a more expensive version, that's the black car, getting things like navigation and stuff like that. And then we have a more cheaper version with just the basic functions like a music player and a phone. And somehow we're going to try to provision that software to those different cars and see how we can work with updates and stuff like that. So on my laptop here, we have Apache ACE running. And Apache ACE is the central piece of software that we're going to use because Apache ACE is our provisioning server. And that means that if you want to start provisioning those cars, the first thing that we have to do is take our software, our release software. We upload it to Apache ACE. So that's the central place where we put all the artifacts. And Apache ACE will then take care of actually provisioning, which means sending the software to the different devices that we have. So let's take a look how that actually looks like in practice. So first of all, I have two different screens here, if they decide to wake up again. There we go. So I'm just logged in on the two different devices that we have. And we're going to start a Java process here. That's the first step that we're going to take. But that Java process that we're going to start doesn't actually do anything yet. It's kind of an empty process almost. So I'm going to launch it. As you can see, nothing really happened so far. But what happened now is that we started the Java process with an agent. And this agent connected to Apache ACE, to the provisioning server, and is now basically waiting for Apache ACE to provision something. So it says, well, here I am, I'm a device, and I want to have some software. Please give me something. Well, currently we don't have any software to give because we didn't take care of that yet. But the devices are ready to be provisioned right now. So the next step is looking at Apache ACE itself. And we start the web user interface here. It's quite ugly, as you can see. And that's because in practice, you actually normally don't really use this user interface. The user interface is mostly used for demos, so that you can actually see what happens. But normally, you take all the automation using the different APIs that we have for that. Sander will go into that later on. Because you don't really want to do all this work by hand, but this kind of shows you in more detail what's going on. So on the left-hand side here, I have a list of artifacts. And that's the list of components that I have that should be available for provisioning. So basically, the different jar files that I have for my software should be uploaded here. So that's how we start. I've got a whole list of jar files here. And I can simply drag and drop them to Apache ACE, click Add, and now we see that we have this list of artifacts right here. Nothing happened yet, it's just that they are now available to Apache ACE. The next step is to group those artifacts into different features. It doesn't really matter how we group them. That's something that's up for our own design. But in this case, I want to make three different features. I want to have a core feature containing just a bare minimal of our car software. And then I want to have a budget feature that contains the music player and the phone. And a deluxe version which also contains the navigation. And with those features, I can then group them into distributions. So let's start with our core feature. So we take the core feature, take out the music player, navigation, and phone, drag it to the core feature, click Store. And now we create another feature for the budget features, which is just music and the phone. Drag it over there as well. And a third feature, which is called Deluxe, which contains the navigation. All right, so I've got the features now. You can see if I click it, you see which artifacts are part of that feature. And now I can create distributions. And distributions, again, are just a grouping mechanism. So it's just a grouping to group the different features that we have. So you see that you have two levels of grouping to take your artifacts and well, make some sense of them for provisioning. So, well, we have two different types of cars. We have the expensive one and we have the cheaper one. So let's create a budget distribution and let's take a deluxe distribution. To show you better what's going on, I'm just going to start by only taking my core feature and connecting that to both of the distributions. So the distributions will just contain the bare minimum to run this app, not the features itself yet, but that's nicer to see. And the last step is that I have to connect my distributions to the different cars that we have. So let's say that car 1 gets the budget distribution and car 2 gets the deluxe version. But both are currently equal because they both only contain the core feature. Okay, so again, nothing is showing here yet. But as soon as I start to click Store here, provisioning should start. We see all kind of stuff happening in the screens here. Come back. And we see that we have, well, a very basic application. This is just a JavaFX application, not doing very much. That's because it doesn't contain any of our features yet. It just shows us the version of the software that we are currently running. Yeah, go back, please. Yeah. All right, so the basics of this car software is now running. And now we're going to do something interesting. We are going to keep this thing running. So let's say that the cars are still driving around, but we are now going to provision our more fancy features. So we're going to make sure that they get a distribution that contain the phone, the navigation, and the music player. And again, this is just still running. Someone could still be driving around. So we go back to ACE, and we take our budget feature that we have here, and we connect it to both our budget distribution and to the deluxe distribution. Then we take our deluxe feature, and that's only going to be attached to the deluxe distribution. Again, nothing happens until I click store, but when I do click store, you see things popping up on the running applications. We see that they are not the same, because the one on the right is the deluxe version, so it has navigation as well. So let's see our different features. We have a music player, not doing actual music playing, but just looking like playing music. We have navigation, which is just available to the deluxe version, so this shows us a map of where we are right now. And we have a phone. So we've already seen a few important things. First of all, we have seen that we can start with a completely empty application, just running an agent basically that makes it possible to start provisioning. We can then, without restarting, actually provision new software. And we've also seen how we can have different versions of our software being provisioned to different devices. So let's take it one step further and let's take a look at doing updates. And if you look at the phone application here again, you see it looks very outdated. You know, all the buttons are just squares, and well, that's from last year. You know, we need something that looks a lot cooler. So let's see if we can actually update this application to look a little bit better. And again, let's see if we can do a live update. So we are just going to keep this application running. Again, someone can just still be driving around. And we're going to update the phone application on both. I had already a jar file available that we had prepared containing a second version of our phone. So this is just another jar file. And I start by dragging this jar file to Apache ACE. And the interesting thing that now happens is that if I look at my phone here, you see that there's two different versions. You have the 1.0 and we have the 2.0 version. So Apache ACE still keeps track of all the older artifacts that we had as well. Another interesting thing is that if you click the budget feature, we see that this newer version was automatically attached to my existing feature. It's not provisioned yet. That will not happen automatically. But automatically, Apache ACE will recognize, well, there's a newer version, so the logical thing to do is to attach this newer version to the existing distributions that you had. You can turn it off if you want, if you don't actually want that to happen automatically, but in this case, it's quite convenient. That also means that Apache ACE should understand versioning. So the thing that Apache ACE does is it understands semantic versioning. So it knows how to read version numbers with a major, minor, micro version, so that it can actually make sense of that. So that also means if you use semantic versioning in your jar files when you version them, and use semantic versioning correctly there, Apache ACE can automatically do the right thing. Okay, so let's see if we can actually start this provisioning. So I click store again. And let's open up the phone again. And now we see that it looks a lot better because now we have round buttons. So you see that even without restarting the application, we can do updates of our existing modules that we have. And well, a user doesn't even have to know this. So that's a lot better than, well, the Tesla story that Sander was talking about, where you actually can't drive your car at all when it's updating. So that's it for the first part of the demo. go back to the slides for a second. So what have we actually seen here? Let's compare the thing that we've just seen to a more traditional monolithic deployment. So if you have a monolithic deployment and you start doing provisioning, well, it kind of looks okay, right? You package all your features that you have, probably your jar files if you're talking about Java. You take all the jar files, you package them up in, well, something, maybe a zip file or something, and you send it to the target. That's okay. That's no problem at all, because you have to send it to the targets at some point anyway. The problem starts when we start doing updates, because if you have a monolithic deployment and we want to update one module that we have, so in our case it was the phone module, in a monolithic deployment that would mean that we have to, well, create this huge zip file again containing all our stuff, because there's no way to split it up in different modules, and send everything up again to the targets that we have. If you think about cloud environments, that's really no problem, because we have bandwidth at our disposal anyway. Bandwidth is cheap and it's fast. If you're thinking about IoT and devices in the field, at least for our customers, we often see that bandwidth is actually very limited and very expensive. So you want to be efficient with your bandwidth. You don't want to send updates and well, wasting bandwidth basically by sending features to it that it already has. That's just waste. So here it starts to hurt if you do monolithic deployments. Let's compare that to a more modular approach as we've just seen in the demo. If you start up with your first deployment, well, it kind of looks the same as a monolithic deployment, because again, well, it needs all the features to start with. So the only thing you can do is package up all the features and send it to the device. When doing updates, it does look a lot better though, because in that case, you can just take our new feature that we have, or the updated feature that we want to deploy, and that's the only thing that we have to send to the target, which is of course a lot more efficient than sending over everything that we have. So that's quite nice if you have this limited bandwidth scenario. The other thing that we can really do now, and something that we've also seen just now, is that it becomes much easier to make different compositions of features. So if you have different releases for well, different types of customers, maybe customers that pay or do not pay for certain features, it becomes much easier to compose our distribution of different feature sets. And well, for the provisioning, it kind of all works out of the box. And that would be a lot more difficult if you do monolithic deployments. Let's say that we have a whole set of different features that you can turn on or off, depending if someone pays for it or not. If you have a monolithic deployment, that would mean that you have to create a release or distribution for each, well, each possible composition of those features. And that starts to be very painful very quickly. And we don't have that problem at all if it's more modular. There's a bit of a catch though, because, well, talking about modular provisioning is really nice, and that's something that, well, it's not hard to imagine that you want a thing like that. But, well, modular provisioning doesn't make any sense if your software itself is not modular. If the result of your build of your software is just one big jar file, well, the provisioning server doesn't have any, well, anything to start with to make that more modular. So the first thing that we have to do is create our software itself in a modular fashion. If you look at the Java space, OSGI is kind of the only way to go in that way. Java itself is not very modular. The fact that we have jar files, that's a very weak mechanism of modularity, because at runtime it doesn't actually know about those different modules. So we need a layer on top of that, and OSGI is a really good way to do that. It turns out that OSGI is actually also a very good fit for the IoT world, because it was once designed for IoT. It wasn't called IoT in that, at that time, but we were talking about things like home gateways back then. But that means that OSGI is designed to be it's designed to have very low overhead, so it's very efficient with memory and CPU usage because it's designed to run on devices with, which are not very fast. So that works very well in an IoT scenario. So let's actually take a look at the code that we have. So just a diagram how you would all run it. We have the JVM, of course, it's still Java. On top of that, we just run our OSGI framework. In our case, it's Apache Felix. Again, very little overhead, very lightweight. It's actually very small, so the fact that there's another runtime or another framework on top of the JVM doesn't actually hurt you at all. And on top of that, we create our OSGI modules, OSGI bundles as we call them, and that actually contains our software. So let's switch to Eclipse for a second, and let's just get an impression how this feels like in code. So the first thing that we have is our dashboard. And our dashboard here is kind of our main module that glues everything together. So that's the application itself. But it doesn't contain the features like the phone, etc. So the first thing that we should look at is this interface. And this is an interface that we just created ourselves. You can see it's just a plain Java interface, nothing special about it. But this kind of represents an application. So if we look at the application once more, come on. For example, this screen, this phone screen, that's what we call an app. So this should be represented by this interface that we've just seen. So it has a name, and in the end it just gives us a node, which is part of JavaFX because it's a JavaFX application. But that's just a choice that we made ourselves. We can then look at the dashboard code itself. And the dashboard code itself that contains a create UI method. I'm not going over it line by line because it's, again, all just JavaFX code. There's one interesting part in it, which is this line here, which says we have a collection of apps. And that's a collection of this app interface that we've just seen. And for each application that we have, we want to do a render app. The render app, again, is just a bunch of JavaFX code. But in the end, we just invoke the method on the application to render itself. So we take this node that we returned from the app interface and put that on the screen. Again, you don't have to understand all the code. It's more about how this works in concept. If we then look at the top of this code, we see that this apps collection that we were just talking about is just a collection of service references and apps. And the way that's created is that we have this method here, add app. This add app is annotated with add service dependency. And this is a dependency injection for OSGI, basically. So what we tell the framework here is that every time we find a new implementation of this app interface, so if someone registers a new app, we want to be invoked, and we can add this application to the collection of apps that we have, and render it. And that means that just given this code and its counterpart remove app, which is invoked when an application is removed, we have a dynamic model where new parts of the application, so for example, a new version of an application or a complete new feature can just be added or removed during runtime, and this is all the code that we need for it. So it's a bit more dynamic than dependency injection as you know it, but it's not any more work, as you can see. So let's take a look at how an application actually looks like. So let's take the music player, for example. And the first thing that you see is that it's packaged in its in its own Eclipse project. And that means that it will also produce its own jar file. So we've seen before that we had a whole bunch of jar files that make up the complete application. That's because we just split up all the different parts of the application in different projects, which all produce jar files. These jar files, of course, are not just plain jar files, but they're actually OSGI bundles. But our tooling here, this is an Eclipse plugin for doing OSGI development. It's called B&D Tools. B&D Tools takes care of actually creating those bundles. So that's something that's done more or less automatically. So let's take a look at our music player. We see our music player is just an implementation of our app interface. It contains some JavaFX code here to actually render itself. But besides this JavaFX code, well, there's really nothing to it. You see, this is just plain Java code. The only thing that makes this well, more than just plain Java code is this annotation add component. And this makes this Java class an OSGI service. And because it's an OSGI service, it's registered to the service registry. And that means that this method that we were just looking at, this service dependency method, is invoked when such a jar file is found. So we can now just add new features to our application by implementing a new version of this app interface, take its jar file, which is automatically generated, put it in my runtime, and we're done. There's no explicit registration mechanism anywhere, and that's very convenient. All right. So a few things that we get for free with using OSGI is we can do this hop swapping of bundles. So that's what we've seen during runtime because we updated our phone application. And this actually gets even better during development, because during development, the thing that I hate most about doing Java development is change a few lines of code, doing an npm install again, and restart your app, and well, you know the story. If you're using OSGI and B&D tools, it feels much more like using a scripting language. You change your code, click save, and you're done. No build, nothing at all. So how does that actually work? In OSGI, you have this mechanism that bundles can be updated in a running framework. That's one of the basic design goals that they had when creating OSGI. So B&D tools, the Eclipse plugin that I was using, every time you compile new code, which Eclipse does automatically, it will also generate a new version of the jar file of that module. That jar file will then be installed in the running framework, which is just part of how OSGI works, and, well, you're done. And that means you never have to wait for long Maven builds or restart your application, reinitialize everything. You can just do hot swapping of your code. And because this is completely in the design of how OSGI works, this is not a hack. This is just how it works and how it's supposed to work. And that means it always works. It's just not something that sometimes works and sometimes not, like some comparable solutions. And this is just how it was designed to be working. So that's really nice. The other thing that we get with OSGI, which is also nice, is that we get very explicit metadata about our modules. We will see exactly who is using who. The fact that my phone and my music player are using this app interface and implemented will be explicitly set in the manifest file, which is part of the OSGI bundle. It's all generated, because we do that by doing bytecode inspection. It's all generated, so you don't have to do that by hand. But that way we know exactly which bundles we need when starting a deployment. That means, in practice, that it's impossible to get a class not found exception. Because when you do a deployment, the framework knows exactly which dependency it needs. And if you're missing dependencies, the framework will immediately start shouting at you, instead of, well, thinking that you're done with your deployment and some unlucky user hits a code path that loads some class that was not installed. That's how we all know it. And we get this whole dynamics dependency injection model for free because we have the service registry. We can use annotations for that, so it looks very much like using something like Spring or Java, just a little bit more dynamic, and that's all built in as well. The code is available on GitHub, so you can take a look at it. And the other thing is, this is not primarily about OSGI, that's just kind of a prerequisite to get this modular deployments working. If you're interested in learning more about OSGI, I actually have a talk tomorrow about that, I believe at 1:30. That's the Pulse talk that was just announced. So I will go into a lot more detail in using OSGI in different scenarios as well. And with that, let's talk more about Apache ACE again.
Okay. Thanks for the cool demo, Paul. I think it's really cool to see how you can actually dynamically update your system and do everything in place instead of starting, restarting, and doing it with downtime. So for that, we've used Apache ACE, and Paul treated it sort of as a black box. You put something in, and you draw the nice associations, and then it all works like magic. We, of course, are wondering, how does it work? So typically, Paul already mentioned this, you're not going to do this through the UI. So what you want is that you have a build server or some other place where you're actually building your software, and you want to push your artifacts to ACE in an automated way, and you want ACE to provision these artifacts to the devices that you've attached to it. So what you see here are the main components of an Apache ACE setup, and what's within the dotted line is actually part of Apache ACE and the provisioning, and outside of that you have the build server that can push things to ACE. And you might be wondering, okay, if I have this ACE server, then I just push to the server. Well, it's a bit more different than that, because there's also the notion of an ACE client, a client library that you use to communicate with the ACE server. So typically your build server will be talking through an ACE client to the server. And there are various flavors of how you can communicate with an ACE client and ACE server, and I'll talk a bit about that later. What's also interesting is that ACE itself is responsible for maintaining the artifact repository. So previous versions, new versions, everything is kept in ACE, so it can provision any combination of artifacts that you've created before. And of course, the multiple devices are all actively connected to the ACE server as well in this architecture. So just to reiterate what we saw in the demo, we have the artifacts on the left-hand side. In our case, in our demo, those were all jar files, but it doesn't have to be that way. ACE calls them artifacts because it's more general than just being able to handle OSGI bundles. In that sense, it's an extensible model, and we'll talk about that towards the end of the talk. So these artifacts are grouped into features, which are more logical groupings of these bundles into logical features, and the distributions are more about, okay, who gets to see what features in what combination. And you can do that based on whether someone is paying more or less, or you can do that based on the capabilities of the device. That's really up to you how you create those associations. Looking at the targets, things look a bit different. We only need a JVM there, and on this JVM we can start a really minimal OSGI framework, and it contains this management agent bundle, which is actually the thing that connects back to the ACE server. So you can really run this on any device that can run a JVM. So one thing that you do need to take into account is that a target needs a unique ID. So either you need to see that when delivering the device, or you need to somehow get a unique identifier from the system configuration of the device. Or, there are multiple ways to do that, but you need to somehow be able to distinguish between the devices when it connects back to ACE, because that's what the management agent will be doing. It will be looking at the configured location of the ACE server, and it will contact and say, okay, I'm a device with ID XYZ, and please give me the software that's designated for me. So, and once this first contact has been made to the ACE server, the deployment packages or deployment package will be sent back to the management agent that's running on the device. And at that moment, you have your software running there. So that's the moment that we saw this dashboard popping up in the demo. That's where we saw that the deployment package was installed on the target and successfully ran there. So in our wish list, I talked a little bit about security and how we don't want just anybody to be able to run software that's part of the provisioning process. There are several ways that you can do this and set this up with Apache ACE and the targets. First of all, in our demo, the targets just connected to the ACE server and we could just provision to them and it all worked without any configuration. You can also configure ACE to have a more explicit registration process. So not just anybody that connects will be accepted as a target. So that's the first step. Another thing that you can configure is to use HTTP basic authentication or even use SSL client certificates from the devices to do the authentication with the ACE server. So then you can be really precise about who you allow and who you don't allow, and it's secured as well. So more from a process perspective, when looking at security, you might want to have manual update approval instead of the automatic approval that happens when we did the demo in the UI. There we just put in a new bundle, clicked on store, and it just all magically happened to be propagated to all devices. In some scenarios, you want to have more control, and that's possible. You can also attach properties to either distributions, features, or even the targets. And these can be used to influence later decisions on what is provisioned and how it's configured. And last but not least, we were talking about provisioning software to the devices, but actually what Apache ACE offers is also a way of communicating back. So what targets do is that they send back audit logs to the Apache ACE server so that you can see and track what has been updated and whether it was successful or not, and all kinds of other metadata will be sent back to the server so you have a centralized view of what's happening with all your devices. So if you want to talk from your build server or other software to ACE itself and do automated provisioning, you have several options. So the most widely applicable one is the REST interface, of course. You can just use it from any language as long as you have HTTP connectivity to the Apache ACE server. And all the features and associations and uploading, etc., that Paul did in the demo, you can do that through corresponding operations in the REST API. If you're already in a Java space and you want to talk just to a Java API, you can do that as well. You see a little example of that there, and you can see the cryptic names. CW is for create workspace, LF is for list features, so you get a list of the features that are in the workspace. So these are meant also to be used in more scripting-like languages, and that's what's mentioned there on the bottom. So you also in the OCI world have a scripting language called Gogo, which can talk to Java APIs, and then you can have really short commands like the CW and LF, etc. And we've used that successfully also from our build server to just kick off these Gogo shell scripts to do provisioning and linking features, etc. In an automated fashion. So what gets sent back to the targets? We talk about them as being sort of opaque deployment packages, and you can think of them just as an archive that just contains the jar files. But there's also a metadata related to the deployment packages themselves, that's shown here. And this conforms to a OSGI specification called the deployment appin specification. So you really don't need to worry about this if you are not really deep into OSGI, but it's all spec compliant and using the appropriate specifications where we can in Apache ACE. So if you install such a deployment package, the nice thing is that if it fails for some reason, it will automatically undo the installation up till then, and it will keep on running the previous state of affairs on that target. So even if you, I'll get to the screen.
Those are the OSGI protocol,
This is programmed on top of the OCI framework using their installation features and uninstallation features. Yes, yeah. So whatever happens, whatever you push to the target, you can rely on if it fails, it will roll back to its previous state and it will keep on servicing the user and the client. And if it fails, you will see it in the central server in your audit log that's being sent back from the target to the server. There are some additional features for getting deployment packages to the targets that have to do with unreliable networks. You can configure the targets to download the deployment package first instead of streaming it. If it's unreliable, that's really helpful. Then you can also resume the download again from a certain part. And you can also plug in custom update strategies into the target. So by default, you have a polling setup where the target, whatever interval you configure, it goes back to the server and says, okay, do you have anything new for me? But you can customize that and maybe only update when you're in Wi-Fi range or only update in some other circumstances. It's totally up to you. As long as you can make the decision using Java code, you can program it as a custom update strategy. And that's a big theme of Apache ACE in general. It's really extensible. And this has, of course, to do with the fact that it's also itself built on OCI, so you can load additional features and customize it in any way you want. You can plug in different repository implementations. You get one for free, and it works fairly well. But if you want to have a different repository backend for the artifacts, that's possible as well. Like I said, you can have custom update strategies. And more an architectural point of view, you can also have multiple topologies. And this has everything to do with scaling, of course, because if you have lots and lots of devices pulling a single ACE server, it might buckle under the load. So there's a concept of having a relay service where you can sort of build a tree of Apache ACE servers that propagate the configuration and artifacts down. And you can talk to many different Apache ACE servers from the devices and sort of shard the load across those different instances. There's also a notion of resource processors, and that has everything to do with being able to handle different artifacts than OCI bundles, than jar files. And what you have to do if you implement such a processor is that you have to implement some interface and some code to actually recognize the artifact that you want to handle. And you have to handle the installation process on the target itself. Because if it's not an OCI jar bundle, then Apache ACE doesn't by default know what to do. And so you have to implement that yourself. And if you have such a resource processor, you can upload it to the ACE server itself. And it will recognize it as a resource processor and handle any resources of this new type that it now can recognize using your resource processor. So an example that has been implemented is to also be able to provision configuration files. And there's this XML configuration standard in the OCI world called metatype. In this file, you can put your configuration for your application, and using the resource processor, it will be automatically translated into an OCI configuration on the target. But you can create any resource processor for any artifact that you want to upload to Apache ACE, as long as you also write the code to handle the installation of this artifact. So to summarize, we really experienced that having Apache ACE simplified doing deployments in our IoT context, in our devices context. But you do really need to have a modular application to reap the benefits of this setup. So since modular applications rock, I really recommend looking into such a strategy, but it's not something that comes for free. And once you have this, you can have a very, very nice and flexible modular deployment setup. So with that, I would like to close, and maybe there are some questions, and if not, we'd like to thank you for the time, and have a good conference.